I'm Dr. Richard Fitton. I work here at Salford Energy House, Energy House 1, as we've had to now call it. So it's down to me to introduce you to the technical side of what we're doing, and also to introduce you to the existing facility and the new facility as well. So this will be a short presentation. It's got a video that I'll talk over in a couple of minutes as well, and then we're gonna carry straight on. So Energy House 1, we opened in 2011, which is a long time ago now. We've accredited ourselves at about 1.5 million pounds of research income, plus a lot of other commercial research on our other units that surround the Energy House as well. And we've always kind of prided ourselves in the whole ambition around retrofit. So retrofit was why we were started, and it's why Nigel Mellors kind of set up the unit as well. And that we think we've made a significant impact around that area. So we've generally worked around retrofit fabric and insulation, air tightness, smart controls is something that we've kind of leaned right into in the last 5 or 6 years. Then along came vehicle charging, things like vehicle to grid, which is a different thing. We've had to assemble parts around the facility to kind of cope with that. Building performance technologies and methodologies is something that we kind of really pride ourselves on. That wasn't what we started up to do, but the idea of coming up with new methods to measure the performance of buildings has been something that's really taken off, actually. And sitting in the middle, you know, we look at the commercial testing of energy savings devices. That's at the heart of what we do as well, aside from the academic research. And it takes up about, I'd say, about 2/3 of our time and income as well as commercial testing. So as you'll see from just a selection of logos on the bottom there, we've worked with some pretty big names, and we also work with some very small names, and we pride ourselves in doing both, really. So it was a world first. That meant it was quite testing at the beginning as well. And any world first is difficult, but I think we got there. So it's used by researchers and industry from all around the globe. We started off with our standard temperature range, -10 to +30. Then we added rain, then along came wind. Solar radiation was our latest addition, and snow is something that we've always kind of done, but maybe not done a great deal of. That might be something that changes in the new facility. And sat right in the middle of that chamber is a fully functioning UK terrace, which is very representative of kind of 23–24% of the UK housing stock. So we did that a long time ago, you know, coming up for 10 years ago, and you know, Will and I sat in an office and we decided that we wouldn't kind of carry on developing in little bits with the Energy House, although it will never stop. And it's with us. It's a fixed asset. We're not going to it's not going anywhere. But we needed to make it a leap. So you know, the step process is nice, but we needed to make a big jump. We needed more space, without a shadow of a doubt. More flexibility. Again, we're tested in that building because we can't do a great deal with it in terms of where it's sat. Accessibility. Every brick that you see in that background image was brought down a corridor. And you know, through a small set of doors, and we constructed it in the chamber. And we needed more environmental variation to cover a larger proportion of global buildings, particularly global dwellings. So that's kind of what we set ourselves the task to do. And we set ourselves that task 5 years ago, more or less, not far off to the day. And the background you see there is my idea of a blank sheet of paper. So we started off with a blank sheet of paper, and this was this pen sketch that was done on my desk at one of our early morning meetings. Will and I was our idea, and it's all hopefully built on this. And the idea was we build a big thing and we put a number of different houses in it, and then we make it so big that we can build inside, and we have big doors so we can get big plant in. So the idea was big, you can safely assume. That then went on to a initial design. So we came up with this idea of having 3 chambers, and we put different houses inside them, with the idea that the plant rooms would divide the 3 chambers. So that was in 2016 by the time we got there. So all these things take time. Then we had this concept, and the concept there was a really beautiful building surrounded by beautiful fenestration all around, and it was lit from the inside, and it was an amazing building. 3 chambers with a street scene running all the way through it. So basically you had a street running the length of the chamber. That kind of went through a process of value engineering, as these things always do, and we ended up with this type of building, which are simpler, sleeker, and a little bit smaller as well. And after a process of value engineering further, 2018 we finally got there. So 2018 saw the final design, if you like, the final more or less frozen solution. And this really is a building that we are constructing at the moment. Okay, so this is our basic building that we're working on now. And it's going to take you on a tour around the site. So we started off with this idea: we have to have a big building, we have to get big plant in there. We needed 2 large chambers, and we also needed somewhere where we can build inside. And to build inside, we need things like foundations. So we need big pits that sit inside. So the big pits that sit inside allow us to build houses actually inside, the same as we would build in the real world. So the ground, the soil, the conditions in the soil affect the performance of the building. We also needed to allow for plant, cranes, things like that to get inside and to build the houses, actually in the chamber environment. And for scale there, we've got 2 houses on the right. There's Energy House 2. So if we Energy House 1. So imagine if we dropped Energy House 1 inside, we could get 2 versions of the same building. So we can get 4 houses, 4 moderately sized detached houses within the chamber. We can also put cars next to them. So cars are a considerable part of an energy, of a full energy system within a building now. And the idea of vehicle to grid is one that's accelerating really quickly. The climatic chambers we needed to be deeper and higher. So -20 to +40 gives us this whole idea of covering 95% of the global population, not the land mass, the global population of where people currently reside. So that to us was really important. And this idea of getting different buildings from all around the globe and putting them in one place where we can run them through a series of climatic conditions. So you see it here snowing, and then you're going to see things like snow and wind and rain cropping up as well. So this idea of having a building that can put another dwelling through exactly the same climatic conditions of more or less anywhere on the globe is a fascinating prospect. So we can take a building from China and see if it works in China, and also if it works in Manchester, for instance, and any kind of any place in between the two. And we can do that extraordinarily quickly as well. So, we talk in field trial language of around a year to put a package of measures together. So then we have this whole idea of not being able to test just houses in there. So the automotive industry has approached us a number of times and asked us to test cars within there. Caravans has been mentioned, sleeper rigs on wagons and things like that. We can really test a lot of different things within there, and we can couple other things inside it, such as hospital wings. We've talked about with the NHS Trust locally. So there's a lot of different things that we can do. So I'm just going to bring my slides back on now. So where we're currently up to. So I can speak very safely where we're currently up to, because I was stood in the pit where that gentleman was stood there only yesterday, in soil sensors and temperature sensors into that mud. So we're at the point now where the foundations are poured, the chamber pits are excavated. So this is the exciting bit. We're down in the mud now and putting our own sensors in. These are the pits where the foundations of the actual buildings that we construct in the chambers will be constructed. It's scheduled to be complete in December 21, so that's practical completion. So that's the point when we will start putting our monitoring systems in there, and other homes will start to be built in there, and we open to the public in March 2022. So here's some ideas of kind of where we're at. So you see all the pile caps are all in, the chamber pits will be poured, I think the beginning of next week. So we'll have 2 large concrete chamber pits cropping up. Then we'll start the steel work. So as you can see, it's all going on the site. For those who are like me, who are interested in these things, if you click to the Energy House 2 website, the link will be on at the back of these slides that we do today. There's a time-lapse camera on there, so you can get a fascinating kind of bird's eye view of every 10 minutes. This gets updated, so you can see how the site is progressing. That camera will move around the site as we come to approach different parts of it. So we're also looking to partner with industry and academia globally and locally. So, you know, we are very interested in talking to people in the business of off-site construction, people who are looking at small commercials, hospital wings and things like this, which we've seen develop very quickly as the ongoing pandemic has kind of made us build these things quickly as well, and temporarily. Novel construction methods, I think, is always something that we're interested in. Energy systems and the idea of assembling buildings with PV, batteries, V2G, different energy vectors as well, such as hydrogen, are all something that we are aiming to develop, you know, significant testing abilities in that property as well. And the automotive industry and thermal performance is something that we are really interested in at the moment. So I personally believe, and I hope there's a lot of people who would agree, that this is a pivotal moment in the energy performance of buildings. This is where we can start to dig deep into what we're doing in terms of off-site, modern methods of construction, and different housings that occur all around the world. And this is not houses, it's emergency shelters and things like that, the really important stuff. So we've got research grade sensing systems providing really reliable results. We cover the main energy vectors, so gas, hydrogen, electric, PV and ground source will be covered in there. We're looking at systems, not just houses. So this is how a fabric performs with the car, the battery, the PV, the air source and occupants. So Energy House 2 is designed with a specific intent that people can live in all of those 4 houses. Energy House 1 fell down slightly in there, but you know, we have people in there for short periods of time. This building, people can live inside the houses that are built. Rapid validation of energy performance. You know, we're talking weeks and months, not years, to roll it through the entire climate of the country and the entire climate of the several countries, if we wish. And we get customer feedback in real world settings. So we can put people in a building looking at thermal comfort. We can say, what was the building like in the winter? What was it like in the summer? And we can run through that process in a couple of days. And then people can actually tell us what they feel before we start doing it. And if we find things wrong, which we inevitably will, because it's the construction industry and these type of things happen, we can make the improvements instantly and retest and find out what the actual difference was. So if you want to get involved, this is the email address. It will be on at the end of the slides as well. This is the website with the links to all the live stuff that's going to come on there. That will now become more live now we've launched the property.